Hello, in this video I'd like to present two challenge problems for you, and I'm going to pause the video and give you a few minutes to work on these, and then we'll come back together and post the solution. So the first graph, I'm asking, is there a Hamiltonian circuit? And if there is, go ahead and find it. And you can do that by coloring the edges in or just listing the vertices that you travel through. And then in question number 2, I'd like to know, is there an Eulerian path? What about a circuit? And you don't have to actually identify it. You can if you want, but you might be able to use one of the properties of even or odd degrees, things like that, to answer the question. Okay, so let's look at question number 1. I suggest that there is a Hamiltonian circuit, so let's go through and identify that. So I'm going to start at vertex A, and I'm going to travel along the edge to B. So I've visited vertex A, and I've visited vertex B. And then I'm going to travel to C. Then I'm going to go to D. From here, I'm going to go to E. Now, I don't want to go back to A because I've already visited vertex A, and Hamiltonian circuits are all about the vertices that you visited, not necessarily the edges. So once I've hit vertex E, I'm going to drive in and hit vertex F, and then I'm going to go O, N, M, L, K, J, I. Then I'm going to drive in and hit R, S, T, P, Q, G, and H. So that covered all the vertices, and if I want to start and stop where I ended, I'm right there back at A. So we could list this, and if we want to list the vertices here, it would be A, B, C, D, E, F, O, N, M, L, K, J. Then we did I, R, S. Let me make a bit more space here. T, P, Q, G, H, and back to A. Okay, so for question number 2, let's go through and look at the degrees of the vertices, because that will give us some very helpful information about what's going on with this graph. So if I look at the little corners over here, this vertex right here has degree 2. This vertex on the end has degree 3. Get that to type, oops. And down here on the corner, that's got a 2. And so over on the other side here, we also had the 2, the 3, and the 2. Now, what's going on for all these middle, or I'm going to call them interior vertices? They're all quite the same. So if we figure out one column, they're all going to be the same. So if we look here, I've got a degree, let's count in the number of edges that are incident here. We got 1, 2, 3, and 4. So this is degree 4. And the same thing is true for the bottom vertex down here. This is also degree 4. And then in the middle here, that's also degree 4. So I can just put a 4 right there as well. So what we found is that we have most of the vertices are degree 2. So what we found are most vertices are even degree. They're 2 or 4. We have exactly 2 vertices of odd degree, and that was the 3 and the 3 we found at both ends. And so recall that when we have at most 2 vertices of odd degree, we do have an Eulerian path.